Hello and welcome to the BITZER Web Forum. My name is Volker Stamer and as the director of the Schaufler Academy, the BITZER Training Center, I wish you a warm welcome to our Refrigerant Expert Forum. In today's live stream, we want not only to introduce the 21st edition of the Refrigerant Report, but also cover the actual issues concerning refrigerants and also emphasize a discussion and inform about future possible scenarios. We broadcast live from our new headquarters in Sindelfingen, which was completed in 2019, and with 75 meters, it's the tallest building here in the area. With this building, we are not only setting an architectonical and technical milestone, but also give a clear statement to our roots, since BITZER started here as a small mechanical workshop. In order to start a real and live discussion, my dearest spectators, you can actively participate by asking our expert team here via chat. So the chat is below on the screen. You can type in your questions there. We will cover these questions at the end of this broadcast, even after official transmitting time, so we will respond in due time. Thank you so much. My guests today are my colleagues Julian Pfaffel, Head of Product Performance, the department where not only product performance data are gathered and measured, but also where our BITZER selection software has its origin. It is clear that his department's daily business is to be up to date regarding the variety of refrigerants and implement all data into our software. Julian is also chairman at ASERCOM and responsible there for certification. A warm welcome, Julian.
Thank you, Volker.
Next to me is Dr. Heinz Jurgensen, Director Application Engineering and Product Performance, the team that deals with all kinds of applications of our products, and also have to cover the use of these refrigerants in a daily use. His employees and also himself are active trainers in the Schaufler Academy. Heinz is also active in lots of associations and is in the advisory board of the Standardization Committee Refrigeration at the Dean. Also, welcome, Heinz.
Thanks, Volker.
Last but not least, the father of the Refrigerant Report, for which he got the honorary medal or honorary coin at the DKV, is a very active member in lots of associations such as ASERCOM, Euramon, and EPE, and also predecessor of Heinz Jurgensen. He considers himself as semi-retired and works as technical program manager at BITZER. A warm welcome to my esteemed colleague Hermann Renz.
Thank
Hermann,
you, Volker.
welcome.
Thank you.
Okay, I hold here in my hands the brand new and still warm from the printing machine issue, the 21st issue of the Refrigerant Report. Hermann, we are not a producer of refrigerants, so can you tell us a little bit more about the history of this booklet and the origin of the report and why you started it?
Okay, I will try to make the longer story a bit shorter.
Okay.
In 1974, well-respected scientists raised a warning about the depletion of the ozone layer by CFCs. And during the 1980s, this was confirmed by the discovery of the ozone hole. It was obvious that a ban of CFCs will follow, and since CFCs have been widely used in particular in commercial refrigeration, but also in fridges, etc., there was some uncertainty how to continue. As a transitional solution, R22, which was already widely used in air conditioning, in larger commercial application, and also in industrial applications, was used as a single fluid, but also as a component in newly developed blends to substitute R12 and 502. The next generation of refrigerants have been the chlorine and bromine-free HFCs, in the forefront 133, but immediately followed by a couple of mixtures in order to substitute R22 and 502 mainly. And you can imagine these rapid changes within our industry raised a lot of additional questions, so customers were unsecure in the one or the other topic. In particular, the HFCs had some further challenges. It was not only the change of the refrigerant, it was also a new requirement with regard to material compatibility and, of course, with regard to the lubricant, in particular related to the high polarity of the HFCs. So customers raised quite a lot of questions and asked for guidance, and so we started to write it down, and this was the start of the refrigerant report.
Okay. I have also here the very first edition of the refrigerant report in 1992. So this was the basically the grandfather of the refrigerant report, and behind that the great-grandfather, which goes back actually to 1988. So that's quite a while ago. We now know what you did in 1988, but Julian, what about you? Did you have already something to do with refrigerants?
In 1988, I think I went to elementary school and had no idea about refrigerants.
I was just finishing high school and had no idea which way to go, but it led to me. But maybe Heinz, had you already dealings with?
Yes, I already worked at university, and in the lab we created our own refrigerant blends for the testing there.
Okay. All right. Let's go back to the actual topic here, to the brand new one. Typical question: what's new? What are the news? What is the current development trends, and in which kind of applications?
Yeah, for a typical question, I have also a typical answer. As you can imagine, the refrigerant issue is still a burning topic, and for the foreseeable future will also stay in the same kind of requirement. Developments in the last 2 years since the last edition have been in particular low GWP refrigerants, mainly refrigerant blends, but against former time also for special applications, which was not so much in the forefront before. But however, also with regard to natural refrigerants, halogen-free refrigerants, new developments have been taking place, further development in system technology and so on. If we look to this structural situation, you can see these two blocks on the left side in green, the low GWP refrigerants. They are single fluids, quite a list, and then of course also blends. In natural refrigerants we mainly use the single fluids, and the variety, as we can see here, is much less than we will see in a while on the side of the low GWP alternatives.
Can you go a little bit into greater details here and be a little bit more specific?
Yeah, okay, on this table, we see on the left side, on the column of the left side, the current refrigerants or refrigerants being used so far, which is 130 for A, 400 for A, 507A, R22, not so much in Europe, of course, 407C and 410A. And on the top, in this green frame, okay, it appeared now, we can see a list of candidates of pure refrigerants, starting with 1234YF and ending up with natural refrigerants like propane. There's also CO2 in the list, but the potential candidates are limited and can be used then for mixtures to cope with the requirements of the original refrigerant. So the aim is to meet the thermodynamic properties to the best extent. But one of the major goals, and this also by legal requirement, and there's a lot of driver behind it, is to develop refrigerants for the lowest possible GWP. And if you look to the second and third column, then we can see the safety group on the left side and on the right side, the GWP. And the lower we come with the GWP, then we will see that we are suddenly ending up in A2L category. This means mildly flammable, but anyway flammable with certain very specific requirements. There are a few exemptions with regard to flammability with low GWP values. These are typically so-called low pressure refrigerants. We will hear about a bit more later on. They feature very low global warming potential and are still not flammable. But we have to say the volumetric refrigerating capacity of these fluids are rather low, and usually also the boiling temperatures are relatively high, at least above zero, and so they cannot be applied in typical refrigeration systems. So on the next graph, we will find again the candidates used so far on the left side, and then alternative refrigerants and blends in the next column. This list is only concentrated or an extract of fluids which are already commercialized and also being applied in practice to a certain extent, more or less. So on the upper side, we can then see the alternatives to 133. With 133, we are still in a very good position. Even refrigerants down to about 600 GWP are not flammable. This looks different with 507 and so on, and in particular with 410A. The full list of alternatives already listed by ASHRAE is also shown in the refrigerant report.
So we have it in here, yeah. Okay.
What we can also see on the very right side, in particular with 403, 507 alternatives, going down in the GWP, also ends up in a distinct temperature glide. This has to do with the components which are available with very different boiling temperatures. This is the reason for this.
Okay, coming back to the flammability, why flammable A2L refrigerants when there are non-flammable A1 or lower GWP refrigerants available as well?
Yeah,
Heinz.
That's a good point. Yeah, we have in European Union our F-gas regulation. The F-gas regulation gives us a limit on how much fluorinated greenhouse gases we can emit. The total amount is calculated by the tonnage times the individual global warming potential. I have tried to show that with the big bottle in the top, with the capital letters, the large letters of the global warming potential. And as we, over time, have to step down the steps and reduce the total emission, we can either go, let's say, stay with the non-flammable high global warming potential materials and limit the amount we are using to down to 20% around.
Okay.
But in practice, this has shown not to work. Also because we get more and more applications of refrigerants, like in heat pumps to save energy in heating, like in air conditioning for high efficiency buildings. And that means we stay on the other path with the large amount of refrigerant, so we have to reduce the global warming to the small letters, to the small amount. And when we do that, we must realize that in chemistry, those components in the molecules which increase the global warming are also limiting the flammability. So as Hermann said, when we lower the global warming, and we have to go that path, it's the most practical way, then we will typically end up with flammable substances. And so there's a small flammability symbol there. In certain cases with low pressure refrigerants, we just come around the flammability, but only for limited applications. In many applications, we can take CO2, which is a different system design, but the vast amount of applications, we have to use also refrigerants, which are still the chemicals, possibly A to L, because we have so many applications that we need all the possible solutions to apply. And yeah, the difficulty is now there's a lot of blends coming up, as you mentioned, a long list, and all these blends, all these new materials, they put quite some workload on us as component manufacturers.
I can imagine, yeah.
You're absolutely right, Heinz, and especially for research and development, the large amount of new refrigerants is a real challenge. We have to investigate or the material compatibility, different lubricants, and we have to look on the risks of the flammable refrigerants. And of course, we have to do a lot of stress testing. In the past years, we did a lot of testing for application envelopes, for example, for A2L refrigerants, or performance data in full and in part load. While we have nearly finished now our qualification program for scroll compressors and for screw compressors for A2L refrigerants, we were focusing on the last months on our Ecoline compressor series and on our Ecolite condensing units. Here we have qualified and published performance data for the refrigerants 454C and 455A as possible substitutes for 404A, 448A, 449A with a GWP below 150. And we have published performance data for 1234YF and 1234ZE as substitutes for 134A. Yep. We put a big focus also on the investigation of the temperature glide, especially for our condensing units, to evaluate the influence on the eco-design performance data and on the seasonal efficiency.
Thank you, Julian. Talking about that temperature glide, what is it all about and what are the challenges and consequences with this regard?
Yeah, that's a topic which has not been so common in refrigeration. The typical refrigeration topic would be a refrigerant where we expect it when evaporating at constant pressure, we would get a constant temperature, like the blue line shown in this diagram. During the evaporation process, we have constant temperature, and then at the end, a small increase, which we call a superheat. Now, when you have a mix of different components with different boiling points, you get a change in temperature over evaporation. So starting from a lower temperature, we increase the temperature like the light blue dashed line here, showing here is 4 degrees temperature change during evaporation, but you can also see you can tilt even more when your temperature glide increases. So that in this diagram wouldn't look so bad, but also the superheat increases a little higher. And you can see the yellow line at the top that symbolizes the, for example, air we are cooling. And if it comes too close, then we have difficulties in controlling superheat, and losing the control also means losing efficiency. Especially if we have high efficient evaporators with small temperature differences, the chance to get close with these two or collide is big. So if the system is not designed for a temperature glide, there might be losses in efficiency. Okay. Similar as Julian mentioned on the condensers of condensing units. If it's designed for small temperature differences, we have to remember we have to fully condense. The full temperature glide has to be above the ambient temperature. So in many cases, we might end up with higher condensing temperatures than we had before. Higher condensing temperature would also there be loss in efficiency. And we have regulations demanding for minimum efficiencies.
Thank you, Heinz. There the question pops up in my mind, isn't it possible to replace, in general, in refrigeration, air conditioning and heat pump systems, the HFCs by natural refrigerants? Hermann, if you want to answer that?
Yeah, this is quite a good question.
Yeah.
With view on pure thermodynamics and energy efficiency, under the consideration that the different fluids are applied in the right kind of application, nothing speaks against it. There might be a few exceptions in some niche areas. However, the greatest challenge is in the commercial appliances, and there we have to see that the installation and the location of installation are so manifold across the line of all these installations that the safety requirements of hydrocarbons, of ammonia and CO2 cannot always be followed.
Okay.
This is a certain critical aspect. Furthermore, we have to see that the use in this field of operation is traditionally over decades focused on A1 refrigerants only. And this means that also the education, and we have to look worldwide, is at this particular level. It is not so easy now to do extensive training within a short term. This will take, and you know it best,
Yeah, we're
this
working
will
on
take
that.
time, and it's not so easy to be transferred to a wider scale. However, we can immediately see nowadays that the use of natural refrigerants has extended severely. As for example, the great success of CO2 as a refrigerant in supermarket applications, some other applications as well, but also with hydrocarbons and ammonia, new developments are on the way up. And examples, as for chillers with propane as a refrigerant, and special measures for safety and ventilation systems. This is a new trend with hydrocarbons.
In our new building, we have this propane chiller as well.
Yeah.
Yeah.
So, and an additional example with ammonia, there is a strong trend towards so-called low charge systems, which is driven by the safety requirements, of course. If we now look to this chart, we can see now the main candidates for the natural refrigerants. This starts with propane, which is already used to a good extent. Isobutane in household appliances. This is more or less a state of the art, but let's say our focus is more on the side of commercial and industrial applications. And of course, the third candidate in this list is propylene, R1270. As we all know, and looking to the middle of this chart, the safety group, they are highly flammable, and this is a certain challenge. And what I mentioned at the beginning, this cannot always be fulfilled with regard to safety requirements and installation conditions and so on. But from pure thermodynamics would be suitable to substitute R22s, 502s, and 400 forays, etc. So then on the lower block, we can see ammonia, which is in particular suitable due to its thermodynamic properties for larger applications. And traditionally, it is also used there in industrial application, and this will go on also into some areas where other refrigerants are used so far. Then the second candidate, very famous in the last years, CO2. This features also from the safety group, A1. Classification means not toxic, not flammable. Insofar it is quite good, but we all know the pressure levels are quite a demanding factor for components and also for the technology as such.
Yes, Herman, you're right that CO2 is a big topic, and also for BITZER in commercial refrigeration for medium and larger size systems, we focus very much on CO2. We offer here several compressor series which are continuously extended, improved in efficiency, and also digitized in the meantime. To support here our customers with the selection of this system, we have established in our BITZER software the CO2 system calculation tool, our so-called CO2 booster tool. And here we will support our customers by selecting complete CO2 systems with the low temperature stage, with the medium temperature stage and the compressors, the parallel compressors, the air conditioning, the heat recovery, and even the frequency inverters. And with just a few clicks, you can select your system and optimize it. But we also see the trend that CO2 enters in the field of industrial refrigeration, and we also support this by extending our compressor series towards higher displacement and higher capacities, but of course also focus here very much on ammonia as a refrigerant. Therefore, we have also here extended our series from the OS 85 to the OS 95, more than doubled the capacity, and we have documented this in our BITZER software for performance data from 100% down to 10% capacity with our double slider system.
Okay, thank you, Julian, for mentioning the commercial and industrial application. But what about special solutions or more special applications such as high temperature application, ORC, the organic ranking cycle application, or ultra low temperature applications? Can you tell us a little bit more about that, Herman?
Yeah, okay, already with few on the commercial side, one can understand that the development of fluids for this kind of application was never in the forefront. But in the meantime, there are some quite interesting new developments. And we can also in particular see new fluids coming up to substitute HFCs or even HCFCs, like in the turbo business, with alternatives which are quite suitable and can efficiently be applied. If we first have a look to this chart, now on lower GWP alternatives for extra low temperature applications. If you look to the lower part, in these applications, to a good extent, R23, not 32, it's 23, is applied with a very low boiling temperature. It can easily be used in cascade systems, in stress equipment, temperature stress equipment, and so on and so forth.
Okay.
The very bad side of this fluid is the extremely high GWP.
Yeah, 14,000. Yeah.
More than 14,000. So if we now look to the alternative candidates on top of this diagram, then we can in first place see the ethane R170 with very suitable properties, low boiling temperature, no temperature glide, but the negative aspect is the A3 classification means highly flammable, and so far it can be applied, of course, to a good extent, but not easily in general. Very often this stress temperature test equipment is located in the middle of a production facility or in labs, and to install ventilation systems and other equipment for safety reasons is not so easily possible. Then we see the CO2, which, as we heard already, is widely applied then in supermarket systems. It's a beautiful fluid from principle, can be applied also in extra low temperature applications, but due to the dribble point of around -56, it is limited in its application. to about minus 50 evaporating temperature. There are developments in a certain direction which may allow to operate it at lower conditions, but this is still development and research. Then in the middle, we find a refrigerant called R469A. This is a blend out of CO2 as one of the main components, mixed with R32 and 125. And safety group is A1. Temp, the GWP is only about a tenth of R23. Insofar, it looks quite promising.
Yep.
There is, however, a certain drawback due to the very different boiling temperatures of the individual components. There's severe and distinct temperature glide of around 17 degrees at boiling conditions. So it is suitable for certain applications, but it's not a full substitute for all applications of nowadays. Freeze drying is also quite a wide application for R23. If you look then to possible future candidates, then we see the 744A. Like CO2, it has a molecular weight of 44, therefore the name for it. The interesting side is the boiling temperature is close to minus 90. So from this point of view, would be quite a good substitute. The GWP is around 300. From this point, would be quite on the right direction. Unfortunately, this fluid has some properties. It's narcotic. It is also there are some specific challenges with material compatibility, and there are also the danger of exothermal destructions. Insofar, to use this refrigerant as a single fluid is so far not inside. So, however, there are tendencies, and these are research projects, to phlegmatize the 744A by an addition of about 15% of CO2. Of course, the boiling temperature rises then, or the dribble point rises in any way, but there are options then to apply these fluids. However, there are still challenges with regard to lubricant and also chemical stability and so on. So these are research projects going on.
So we covered now the ultra low temperatures. Let's go to the other side of the temperature scale. How does it look like for high temp application and the ORC, for instance?
Okay, if you look to the next chart, and can you go ahead with the lower part? Basically, we have there to substitute R123. However, this is a business with large turbo compressors. It's still an HCFC. Insofar, there is no question that this has to be substituted within short. 124, which is widely used in high temperature heat pumps so far, but mainly in grain cabin applications like in foundries with very high ambient temperatures. And the 245FA is widely applied in organic Rankine cycle systems for electrical energy generation out of waste heat. And so all these three fluids have to be substituted in future. So we can see new developments. Or in the first block, we can see R1224YD and going down to 1336 MZZ. The interesting point is that the boiling temperatures are, of course, far above zero. This limits the application for refrigeration, typical refrigeration, and but they feature in the safety group an A1 classification. And despite of the very low GWP, between about 4 and 8, and this is what Heinz mentioned before, these typical low pressure refrigerants feature the advantage of being non-flammable, not toxic. They can be applied in high temperature applications, also in organic Rankine cycle. The next block with 1336 MZZ and 514, they are very direct substitutes of 123 if you look to the boiling temperature and also to the critical temperature, but they are also very suitable candidates, at least from thermodynamics. There is no long-term testing being performed so far for ORC or high-temperature heat pumps. The lowest block shows hydrocarbons again. For high-temperature applications, they would be very suitable at 600 and 600A with very, very high critical temperatures of between 135 and 150 degrees, which means they can be applied in condensing temperatures far above 100 degrees with relatively high efficiencies.
Okay, it seems that this remains an interesting and challenging topic. Julian, what's new regarding high temp applications like heat pumps, for instance?
Thanks for the question, Volker. Also in the field of high temperature heat pumps, we have some news to report. We will publish a new version of the BITZER software next week, where we will integrate performance data for our CSH compact screw compressors and our Ecoline reciprocating compressors with the refrigerants R1234ZE and R515B for condensation temperatures up to 95 and evaporating temperatures up to 35 or 40 degrees C. For the Ecoline compressors, we have here introduced a special H series to cope with the requirements or the high demanding requirements of the high temperature heat pump. The refrigerant 515B is very charming because with a GWP of just below 300, it's non-flammable and can be used in high temperature heat pumps, but also in traditional air conditioning applications. 95 is a good point, but we will also, or we want to go beyond this to 125 degrees C condensing. This is where we are working on at the moment in the development for our screw compressors. Here the development goes hand in hand with the expander development. In the expander you can use waste heat at a temperature level of 140, 150 degree C, and in our ORC process transform it to electric energy. Coming to the low temperature area, we have also some possibilities here due to the due to the phase down of the high GWP refrigerants. There are not so many alternatives left, or they are very expensive for this for the very low temperature application. So one possibility would be R170, the hydrocarbon in our Ecoline compressor series. That would be one option. Another option would be to use our two-stage compressor down to minus 65 degree, evaporating with, for example, 448A or 449A.
Thank you, Julian. That we heard now quite a large number of refrigerant names with unspellable nomenclature in the meanwhile, I guess. Are there any useful tools to find a little bit a path in this jungle of variety of refrigerants? Herman, I think you have something here for us.
You are quite right. With blends, we have reached in the meantime at least 472.
Okay.
This was the status a couple of weeks ago. Possibly there's one more. The refrigerant report is one tool to go a little bit deeper into details. A lot of options are described there. But 2 years ago, we started with a new development of the digital refrigerant report, also with regard to quicker and more intuitive finding possible solutions and information. So it has a quick navigation, as we will see in a while, to individual chapters. And within these chapters, there are links then to particular topics within the report. Also quick links to diagrams, to tables, etc. for additional information. A special feature is the advanced search, which we will also see in a while, function that allows to find alternative refrigerants according to specific requirements to be input. So
that sounds very interesting. If we have the chance, can we have a look at it? Would that be possible?
I think so.
Okay, let's have a look.
Of course, I would like to show you now the digital refrigerant report, which allows you relatively quick information. On the top of the page, you will find information, refrigerants, a long list with individual topics, then also criteria about lubricants and also the application ranges. One of the very interesting topics is the advanced search of a refrigerant. Currently, we are in the need to look after alternatives, and one of the candidates, which is a challenge, is for instance 400 Frey. And if you would look then without defining additional criteria, then we end up with 18 results of alternative refrigerants to 400 Frey. Of course, mostly we have also to define additional criteria, as for instance the GWP ranges, and as for example also the safety group. We would choose in this case A1 or A2L, and can see we end up with 4 results. There are additional criteria to be selected, but for our short view, this is enough for the moment. So if we open now this list of the 4 selected refrigerants, then we can mark them in front and then start. Then start the comparison. So we have now 3 refrigerants selected to be compared, and this starts with a chemical for single refrigerants, with the mixture components for mixtures and so on, with all technical data coming down also to lubricants, boiling points and all kind of additional features, GWP values, and finally ending with a practical limit, which defines the safety group. There are some additional features, quick links to application ranges and also lubricants, and then also frequently visited. These are specific topics. If you want to open the printed report, then you can also click on this. So this is what I wanted to tell you.
Thank you so much. Seems to be a quite useful and interesting tool. Let's say we have now selected a refrigerant, and now we go into the more practical approach for commissioning or maintenance. Is there any useful tool that we can apply for practical guys to basically get information about boiling points, temperature, pressures and whatnot, since they might not be implemented in the measuring devices? Do you have something?
Okay, on the one side we have all the new fluids.
Yes.
Kind of inflation, but we still have a lot of existing systems with refrigerants which are not anymore allowed in new applications. Insofar, we have started a development already 10 years ago with a refrigerant app containing quite a number of the older fluids and at the stage also of the current fluids, to show, let's say, the relationship between pressure, and temperatures, dew temperatures, and bubble temperatures, which are different than with the blends. This was quite a good tool. There were additional information about the refrigerant as such. This was still in table form. At that time, 2016, we had a facelift. And due to the extended range now of refrigerants, and already at that time, we decided we go in the direction of a real ruler. As we had it in the past as a plastic part, but there the number of refrigerants was limited, as you can imagine, very much. So last year, about this time, we introduced then a very new development of this refrigerant ruler with more than 100 refrigerants on it. And we designed this to the purpose of all the requirements in the field. There are additional features in it, which we will show in a while. And insofar, I think this is quite a good tool. For our American participants, only one hint. The default setting after download for your region will be imperial units.
Okay, so it picks up automatically.
Yeah, whereas in the rest of the world we use then the SI units as default. But it is easily possible to change the default in the settings.
Okay. Can we have a look at it as well? Would that be nice? Would that be good?
I would think so.
Okay,
yeah.
let's have a look.
After download of the app, you will see this ruler site, where you will find 3 conditions, basically pressure in the upper slider, and then dew point and boiling point, and of course with 133 as a single fluid, boiling and dew temperature are equal. There is now the possibility to move the slider to the setting required. This is valid for pressures or for temperatures. Or it is possible by pressing 1, 2, 3 to insert manually the condition you may have measured in your system. For example, 3 bar. And then you will get the resulting dew point and boiling point. Let's now go to search. So in search, there is the possibility to select individually, if you know about the refrigerant name, then as for example, you can punch in 44 and all the refrigerants containing 44 will appear on this list. There are also other filter functions, but in our case, we will now select, as for example, 448A, which is quite similar to 449A. And here, against the 133, we can see in the lower part a difference between dew point and boiling point of about 6 degrees. This means we use here a refrigerant mixture with temperature glide. There is also a feature in particular for relatively low pressures, like in our case now atmospheric pressure, with this mountain sign on the upper left part. It is possible to correct the dew and the bubble point. So in our case we stay on about 444 meters, and we can now immediately recognize that the dew point shifted from about minus 39.9 to minus 41. So there is a shift of 1 degree, which to a certain extent can be quite important. And in particular with low pressure refrigerants, this is an important point. Back to search. There are also filterings, filter functions. Possibly we can choose GWP category, then only refrigerants in this category will appear. Settings are quite important. Altitude method, either in meters or feet, or GPS module or parameter sensor, if it's available in the unit. and barometer sensor is always the more accurate value. Then also temperatures, pressures can be selected. We have pre-selected gauge pressure, but absolute pressures can be inserted as well, or preset, bar, kilopascal, etc. Or for imperial units, also PSI, or the temperatures in Fahrenheit. So this was in short what I wanted to tell you.
Thank you for that demonstration. I saw also there is an additional function on the right that I found. Maybe we can have the picture again on the iPhone. Maybe you can describe what this I means.
Okay, to the right of the refrigerant name on the upper part, you will find a sign with I, which means information. And there, like in the digital refrigerant report, you will then find a longer list of properties and technical data, GWP values, down to critical temperatures, etc.
Okay, thank you so much.
Furthermore, in the search function, as well as here on the upper left side, you can also select favorites.
Okay,
so to shorten the list to your purpose.
Okay, very interesting.
Only one additional hint. The app is available since yesterday for download. The revised web app is available now.
Okay.
And if you have selected automatic update, then you will have received the information already.
I did, thank you. Very interesting, thank you so much. That was the status quo now. Let's have a look a little bit into the future. The EU F-gas regulation will remain, I guess, a hot topic. So what are the next challenges, consequences for our industry? And maybe you can talk a little bit or tell us a little bit about possible revision of this regulation. Heinz.
Yes, I will give it a try. Thank you. Yes, I would come back to these phase down steps we started with, where we can see there are some small arrows indicating that the next step down is 2021, January. That's quite soon. It looks small in this diagram. The unfortunate thing is that due to illegal imports to the EU, we have not reached the level we should have reached 2018 to 2020. Different estimations say that we might have reached only a small part of that. And if the measures taken for the customs clearances and import control, which also get active 2021, take account of that, then the step down would be dramatical. And the need for more lower global warming refrigerants will increase. 2022 then, the next arrow means that's the next ban of refrigerants with high global warming in certain applications. Specifically for commercial application, we will have a ban for racks with more than 40 kilowatt of capacity. We have to go below 150 in global warming. And 2025, the last ban appearing in the regulation will be on small air conditioners above global warming 750. 2022 is also scheduled the revision. The revision is already starting with the preparations. The consultants have been chosen for the preliminary study, for the impact study, and for the possibility studies of what to do. So we can start guessing what will appear in that study. And the Commission already had said that they will not make the new revision after 2022 as scheduled in the original regulation, but they will try to give out the draft already in 2021, because 2022 a lot of actions around the EU Green Deal will appear, and it's better to move this a little forward. So we have to hurry up with our comments on the study as soon as we get them. What will appear in the study? The first thing is, if you look on the steps, they end in 2030. So after 2030, there is nothing in the regulation today. And there has to be something, as the EU and the member states of the EU all have ratified the Kigali Amendment of the Montreal Protocol, which gives similar schedules with different time lags for all around the world. And there are numbers there which go beyond 2050. So also we have to take that up in our regulation. And in the last discussion developing this regulation, you could hear that the EU Parliament favored bans, simplifying market surveillance. Like if you ban a substance or you ban a certain amount of global warming, that is easier to control than, let's say, banning a certain level of global warming in certain applications with a lot of exemptions. So we expect again discussion about bans, because the bans are running out. They have all been fulfilled until the revision comes. And it's easier to discuss and control. And in the end, my personal guess would be that from the history, we have never had any revision of regulations on refrigerants which have not been strengthened.
Okay.
So I would expect that the new regulation part will also strengthen the demands here.
Can you tell us briefly again what the impact of the Kigali Amendment means to our industry?
The Kigali Amendment is a regulation which has copied a lot of procedures like this phase-down scenario from the EU regulation, but depending on the part of the world with a different time lag, which means the procedures we are going through now with our industry in the EU will be the same for our partner countries, for our partners outside the EU, just with some time lag. Means for us, we already are in the training. We have some time ahead. We have good chances to use our products already developed, like Julian has presented, also for the same applications then for the countries to follow.
Okay. Thank you so much, Heinz.
Yeah.
I think we still have no boring times ahead of us. Okay,
No.
Thank you so much.
Enough to do.
I would like to come now to the audience questions, but before we do that, I want to thank my guests here for the very interesting discussion so far. Further information you will find in our documentation, like our refrigerant report, either in the printed version or the digital version. Also in trainings, events and webinars in the Schaufler Academy, where we go a greater deal into more practical approach, hands-on parts. You can learn about these topics, handling about natural refrigerants and also A2L refrigerants. But now let's move on to the questions from the audience. So maybe we can, there are already a couple of them. I will cover the first one. What are major considerations to use PVE or POE oil in air conditioning? I think this is an application topic. Maybe Heinz, you can answer that.
To a certain extent, these two oils are very comparable. They have similar behavior. It's a matter of small adjustments matching better to this or that design of the compressor, but they can be used with the same kind of refrigerants. And both are performing well in, for example, scroll compressors, but it is small differences matching the design better.
I think the next question is also an application question. So if we change the lubricant to use another refrigerant, what would be the effect on COP of the system? Julian, maybe you can...
If you change the lubricant, of course, it has a small influence on the COP, on the power consumption of the system. If you change the refrigerant, you probably have to use the BITZER software to calculate the influence of the different refrigerants, and of course you have to check your condenser and evaporators if they can cope with this refrigerant with the temperature glide or things like that.
Okay, thank you. The next question, R1234YF is an important A2L refrigerant. What is the strategic importance of this refrigerant for BITZER, especially with regards to the TFA problem? So Heinz, maybe you can answer that.
Let's say R1234YF is a component of a lot of blends with low global warming. So it is a big part of the solution to get down in the global warming potential of refrigerants. Yeah, let's say, thus it is a very strategic importance for the market. Our compressors can also live without it, with other refrigerants, but for the market, for our customers, it's quite important. And we have a close look on the TFA problem. Our associations also regularly update on the studies on this, and we have started discussing the TFA problem already when we introduced 134A in the beginning of the 90s, and we have never taken that completely out of focus. So we know about that, and the actual status says that, okay, we'll have the next decades time to take a look on it before the next 20, 30 years, the accumulation in nature will not reach a level that is significantly dangerous, even in the worst cases.
Okay, thank you. Next question, is there a perspective for an R410A alternative with comparable refrigerant capacity and a GWP below 150? Hermann, would you like to answer that?
Yeah, there are HFO candidates which look in this direction. However, they have a couple of drawbacks insofar. This is still a research topic, and most probably we will not find a suitable candidate meeting all the requirements in toxicity, flammability, etc. Unfortunately, on the long list of the candidates we have seen before, there is no real potential to come to a refrigerant in similar refrigerating capacity to 410 with a GWP 150 and lower. So the nowadays alternatives, and this is already quite of a challenge to a certain extent, lie in the range of between 450 to 700 GWP. And below 150, we would have hydrocarbons, but there is no hydrocarbon available with a volumetric cooling capacity like 410A.
So still research to be done, I guess. Next question, any negative comments for R508B in ultra-low temps compared with R23?
My dear friend Jerry, 508B in principle is not anymore allowed due to the content of R116. But coming to your question, 508A and 508B have been developed in particular for hermetic compressors because R23 features a very high compression index resulting in high discharge temperatures, and this was a certain challenge with hermetic type of compressors for smaller stress test chambers, and insofar it is an alternative to originally 503, which had about the same properties.
Okay. So that was a negative comment. All right. Which compressors from BITZER are suitable for extra low temperature applications with ethane R170? Maybe Julian, you may.
Yeah, I already mentioned it, that our universal Ecoline semi-hermetic compressor series can be used with R170 in cascade systems down to minus 95 degree evaporating temperature. Of course, you have to contact BITZER to the application engineering to get some feedback about the right lubricants and some other information for the application.
Yeah. Also a good recommendation, when you find something not in the report, ask our application engineers.
Exactly.
Okay, I think due to the time, I would allow one more or two more questions. Next one is quite easy, I think, to be answered. Do you offer compressors approved for the use of propylene R1270? Maybe since you're in the run.
It's more or less the similar, but also our Ecoline compressor series. We have the P compressor series for propane and propylene. We have a complete series from 1.5 to 150 cubic meters per hour to be used with propylene.
Okay. The last question we will continue with that, answering them. But the last question in this live stream: what is the current best refrigerant for ORC application? Is R245FA still best, or will this be moving to one of the HCFO refrigerants? Since you covered it,
of course, as explained also before, 245FA is the candidate of choice for the moment.
Okay.
And if you look to the other list which was shown of candidates, of possible candidates with critical temperatures far above 170 degrees, this is now a question of deeper going investigations, and this requires also testing with regard to efficiencies and so on. But it looks very promising out of this list to find suitable candidates. But it also depends on the temperature level of the waste heat, and insofar there might be the one or the other differences in the options.
Okay, thank you so much. Due to time restrictions, I don't want to stress you more than necessary. I want to thank you very much for the questions. We will continue answering that even after official broadcasting time. Further information you find as well on our webpage, social media channels, and on the event calendar of the Schaufler Academy, where you can get more information about training, events, and also webinars. Here you find the homepage for it. Currently, due to the COVID-19 situation, we extend our webinar offerings, but allow also closed groups, for example, from the same company, with safety restrictions, of course, and smaller amount of people, also live trainings where you can do hands-on parts in the academy. But we are very careful and cautious about this because your health is a really important topic. If you wish to get in touch with us, if you're interested in all kinds of information about Schaufler Academy and its offerings, you can also sign up doing that page to our newsletter. We will continue doing digital events like this. We will support the Chilventa e-Special with digital product presentations, webinars, and a press conference. Here you can get as well in touch and arrange dates with our BITZER experts or register yourself for specific topics. Mid of November, the BITZER Days will follow as well as a digital event. Here we will have invited customers. They have the chance to experience our innovations, news, and product highlights from all kinds of product and service areas. That's all from us today. Thanks for watching and listening. Thanks also for my guests here. I wish you all the best for you and your families, and most importantly, stay healthy and goodbye.